In this example, we're given the graph of a function f, which is its graph is basically half a circle of radius 2. And we want to sketch the graph of the function y equal to 3f of 1/2 of x plus 1 minus 3. So we're going to bring together all the transformations we've seen so far. So first of all, whatever function you have, try to write it as in the following form: y equal to a f of a times x plus or minus h plus k. And I'll tell you what each part does. So the maybe this part, the x plus or minus h, that's going to give us a horizontal shift of plus or minus h. But of course, if it's minus h, it's h to the left. If it's plus h and h is positive, it's h the other way around. If it's minus h, it's going to be h to the left, to the right if h is positive, and it's going to be to the left if it's x plus h, where h is positive. This is going to be a vertical shift of k. So if it's plus 2, you go 2 up. If it's minus 3, you go 3 down. This a here, right? Remember, this is when we're studying f of ax like this. This is responsible. The a is for horizontal compression or stretch. And if a is negative, there could also be a reflection across the y-axis. And if a is negative, a reflection about the y-axis. Okay, and this one, this is when we're looking at a f of x. And remember, that's so I'm writing capital A because I've used the other a for something else. So this is going to be a vertical stretch or compression. And a reflection about the x-axis if a is negative. About the x-axis if a is negative. So we want to write it like that. So going back to our initial function, the one problem is that I've got a half of x plus 1. So it's not of the forms. So essentially you want to factor whatever is in front of x. Okay, first. Okay, so here we've got y equals, and I'll factor what's in front of x. So what was it? So there was 3. 3 is capital A, so that's going to be responsible for a vertical stretch of 3. F of, and this is where I factor what's in front of x. So it's going to give me x plus 2 here. So the 1/2 will be responsible for a horizontal stretch of 2. X plus 2 will shift the graph 2 units to the left. And finally, plus, it's minus 3. Minus 3 will shift it down 3 units. So let's write all this. So that's going to be vertical. So you analyze each part, and then from this you can get what your final graph is. Vertical stretch of 3. This is going to be responsible for a horizontal, not compression. Remember, if for compressions you need to have something above 1. So this is a horizontal stretch of 2. So it's always the inverse of that number for stretch and compression. This is going to be horizontal shift of 2 to the left. Right? It's to the left because it's plus 2. and -3 is a vertical shift of 3 down. Okay, and from this we can recover what the final graph is. What I like to do personally is do it step by step. Okay, so we start with this. Okay, this is F, and maybe I could, you can stretch everything by 3. So doing that, so maybe I should extend this line. So stretch by 3, 1, 2, 3, you're going to get something like this. Okay, so this is actually, if you're just stretching, right, it would be y equals 3 f of x. Okay. Now, if you do your horizontal stretch of 2, okay, you're going to go 3f of 1/2 of x. So now we're adding the horizontal stretch of 2. So we were at 2, now we're going to be at 4. 4, and this is still going to be quite high. So I'm sorry, it's going to be, oh, no, not in blue, in black. So this is actually kind of fun to do. So at 3, like that. You can keep track of some points, actually the vertex, we can keep track of it. So this is 0, 3. This is 0, 3 still. Of course, these are 4 and -4. 2 and -2. Okay, and now what do we do? Vertical stretch. We can shift. And maybe we could do the horizontal and vertical shift at the same time. So now it's going to be everything we want now. So x plus 2 shifts it 2 to the left. 3 -3 shifts it down by 3. So maybe it's nice to look where our vertex is going to end up. So the vertex, you so 2 to the left, well, so we'll go to -2, and 3 down. Just realized I made a mistake. I don't know if you spotted it, but my vertex, actually, when I did my stretch, right, we were at, this was at 2, so when I stretch it by 3, this should be 6. So I just, so 6. So now, okay, so let's keep track of, so our vertex, which is at 6, I shifted 2 to the left, 3 down. It's going to end up at -2, 3. Right? I subtract 2 from 0 and subtract 3 from 6. Yes, I can also maybe identify, because I could see where those guys are going. So this is so minus at -4 and 4. So 4 is going to go like 2 to the left, 3 down. So at 2, 3, 2 -3, like that, and the other one -4. So we'll go to -6. -3. Maybe I can identify what my y-intercept is going to be. My y-intercept is when x is 0. So if I plug in 0 in there, what is that going to be? I don't know. Can I tell? If I do 3 times f of 1/2, replace x by 0, you get 2 here. So -3. I'm not sure if I'm going to be able to get exactly what this is going to be. It's 3f of 1 minus 3. Okay. It's not entirely clear from the graph of the initial function f what f of 1 is. Well, I kind of know, but we need trigonometry, so I'm not going to mention anything here. So I'm just going to graph my function, and okay, so it's not like something like that. Okay, so that's roughly what's going to happen. So so you see generally speaking, okay, how you can transform the graph of a function. Now the next videos I'm going to do this, but with some specific functions.